It's still lagging a little bit, but hopefully it'll get a little better. Okay. All right. Where was I? So the only thing that changed here is the slope decreasing makes it negative. So our function here is negative 0.4t plus 15. Now in C and D, the phrasing changes a little bit. It says increasing by 3% per minute. And this is why I said that I was going to slightly go against what I said before. You could argue with me that it's lagging super bad. Again, oh, Lord. I'm just going to ramble before I write, I guess. No, actually, I guess I should try to write it down first, so then hopefully it pops up eventually. Oh, there it goes. Why now? Lord, this is frustrating. If you see the word or the symbol percent or the word rate, then it's exponential. I don't care that it says percent per minute. The percent wins out over the per language, which is what I was trying to get at when I said that we have to be the tiniest bit careful with just saying that anytime you see per, it's linear. Because in this case, we do still have the word per, but the percent kind of wins out. So if you ever see a percent symbol or the word rate, no matter what else the wording has, excuse me, it's still exponential. So here we want some, now we have way too many A's running around. We have capital A's and little a once it finally catches up again. There we go. So we've got a little too many A's running around, but it'll be all right. So the A naught that's our initial value. So what value did we start at? Well, just like before in the linear cases, we're still starting at 15. But here's where this gets a bit more complicated, and also I should add more space to this question because we're about to run out of space. But so we need to find our A value. But again, remember that A is 1 plus R, and R is actually what we're given here. Whenever you see a percent or the word rate, it gives you the R value, not the A value. Also, yes. Is that better? Yep. Real struggles today for some reason. What was I saying? So A is equal to 1 plus R. And here we're actually given the R value. But R is a decimal, and we have a percent here. So we need to change the percent over to a decimal. So we need to change that over to 0.03. So 3% is equivalent to 0.03. And here's where I'm starting to run out of space. Apologies on that. So then A would be 1.03, and that's coming from 1 plus that R value of 0.03. So the point is the function we want here is our initial value is 15, and the A value is 1.03. Because it comes from the R value being 3%, so 0.03, but then for the A value we have to add 1 to it. Hopefully that makes sense. Whereas in part D, now again, the only thing that's changing between C and D is now we're saying decreasing. So A naught is still the same. But now R, since we're decreasing, R is going to be negative. So negative 0.03. But then if we calculate the A value with that, if we do 1 plus negative, so 1 minus 0.03, we get 0.97. So the function you're looking for is 15 0.97 to the t. Which is essentially why our A value is never 0. because even if we decrease by 100%, then it's just gonna, well, it would be 0, but that doesn't really make any sense because then it would just be constant. But anyway, so A, again, should never be negative. Should always be a positive number. Questions, concerns about that? Are we allowed to leave it like 15 times 1 minus 0.03 to the t? If it's something for me, a quiz or an exam, go right ahead. Wiley will probably get mad at you, I think. Most likely. But if you wanted to leave it on an exam or a quiz as this, I can't really fault you for that because that's technically correct. But I do think Wiley will get mad at you. All right. Any more questions on that before we move on? Okay. 3:30. We go to 4:05. Okay. So I'm gonna zoom out a little bit, try to get this whole thing in here. Come on, zoom. Thank you. A little too much. There we go. All right. Don't you dare start being a jerkwad again today. You want to come in the math lesson? Sorry, I'm talking about cat. Anyway, so we've got, by the 1990s, wolves in Wyoming had been wiped out by hunters and put on an endangered species list. In 1995, wolves were reintroduced. Wait, go back, please. Okay. I'm going to read the problem still once it... Oh, it's lagging. God. Oh. There we go. So I'm going to finish reading the problem, though. In 1995, wolves were reintroduced to Wyoming from Canada, starting with 14 wolves in 1995. I cut off the 1 there. Let me make that box a little better. 14 wolves in 1995. Their number increased to 207 wolves in 2012. Assuming that the Wyoming wolf population is growing exponentially, find the function to represent the population T years after 1995. So we're going back to that kind of convention of years since. And then what is the annual percent growth rate? You good, Parker? Can I scroll back down? Yes, no, maybe. I'm gonna scroll down. I'll try to leave that last one in there. Blink. Okay. So, sorry about that. I'm being a weirdo. So essentially in this, we want to find the equation for the exponential function given 2 points. So just like we could do the same thing for a linear function, we're now going to want to be able to do it for an exponential function. So the first thing I should probably do is actually figure out the 2 points that we're going to be using. So eventually I'm going to want an equation that looks like this because we're told it's exponential. There we go. So we're told it's exponential, so we know we're going to want it to look like that. So essentially the t values are our x's and the p values for the population is going to be our y's. So the 2 points we're working with, well, we had 14 wolves in 1995. Now t is in years since 1995, which makes that point 0, 14, since 1995, 0 years since 1995. And then the 207 wolves in 2012. 2012 is, I think, 17 years since 1995. And we had 207 wolves. So those are essentially the 2 points we're working with. And now I'm going to scroll all the way down. So now that we have the 2 points we know we want to work with, we can now go about finding the equation. Now this process is a bit more lengthy than the linear process, but we got to do it. So the first thing we're going to do is we're going to put both points essentially into the format of the equation that we're going to want. And because I know what's going to happen next, is it? I assume you mean the 17? 2012 minus 1995, 17. 1995 to 2000 is 5, to 2012 is another 12, so 17? Should be 17. If you mean the 17,207. Otherwise, no, you're kidding. What are they saying? So we want to put both points in the form p equals p naught a to the t. Because I know what's going to happen next, I always suggest using the larger t value first, and you're also going to write them one above the other. If you forget to do that, you're just going to have to write them multiple times. But so I'm going to take the larger t value, so the 17, and I'm going to put it into the format of the equation. So our population is 207. I don't know what p naught is. Well, I'll talk about that in a second. I don't know what a is, but t was 17. And then the other point was 14, p naught a to the 0. Now, just like with linear equations, sometimes you have a little bit of a shortcut. So here we could take a shortcut to figure out what p naught is, but I'm not going to because I always want to make sure you have the full process in your notes somewhere. So we're gonna not use that shortcut. I'm gonna talk about it a bit later, but we're gonna do this full out as if we didn't already know what p naught is. Technically, we know it's 14 because p naught is when t is 0. But anyway, so we write them in this format, and then we're going to divide the two equations, which is why I strategically say, suggest doing the larger t value first and write them one on top of the other. Now you might be saying to me, why the heck do we divide them? What the heck is the point of that? And here's the point. We have two things we don't know. And again, technically we have a shortcut for p naught, but sometimes we don't. So there are two unknowns here. So we need to make one of them go away because we can only solve for one thing at a time. So we need one of those two variables to go away. If we divide these, the p naughts cancel out. So that's kind of the point, and why we're dividing these two equations is because it gets rid of one of the variables we don't know. So I'm going to leave this as 207 over 14. You could totally turn that into a decimal if you wanted. And then a to the 17th divided by a to the 0 is going to be a to the 17th. Where do I want to put this? Algebra reminder. If you have something with the same base and you're dividing them, you subtract their exponents. So 17 minus 0 is 17. And then you're going to solve for a. So here we need to take the 17th root of this 207 divided by 14. Or again, you can change it into 1 over 17th power. This is going to be approximately, so let me use approximation symbols, approximately 1.172. So that's our a value, approximately. So now we know one of the values that we didn't know, and now we can go back and essentially solve for the other one. So we're going to use this a value we just found, to solve for p naught. And again, I'll talk about the shortcut because it does come into play a little bit in a second. But say we didn't have the shortcut. What you're going to do is you're going to go back to the original two functions that you had, and you're going to pick whichever one makes you happier. Because I'm trying to do this in a non-shortcut way, I'm going to pick the one that has 17 and 207. What's up, Jackson?
I just have one quick question. With the 17, when you have a equals 17 and then you have the 207 over 14, what do you do with that 17 again?
So you're essentially, to undo the 17, you have to take the 17th root. So like if you had like x squared equals 4, you solve for that by taking the square root of, whoops, the square root of 4, right? So, well, now it's lagging. Oh, great. So similarly, just like you would square root both sides if you're trying to undo a squared, to undo a 17th power, you have to take the 17th root. So I don't know how to show you because it'll blur out my calculator and I don't, and it's lagging. Let me, what is happening? Oh, wait, is that messing with it? Interesting. I think I might know why it's being such a butt. Anyway, so similarly, to undo this 17, this 17th power, Oh, no, never mind. It's still lagging. To undo this 17th power, we essentially have to take the 17th root of both sides to cancel that out and just get A. Once it catches up with me. Lord, I hate this. So we have to take the 17th root of both sides. In your calculator, you can type it in as either this. It'll pop up eventually. I'll just write them out and then I'll talk about it in a second once it catches up with me. Catch up, please, and thank you. Let me just try to unshare and reshare. There we go. So to get that root in your calculator, you kind of have two main choices. You can either type it in as a fractional exponent, that's my personal go-to. Or if you have a TI 83 or 84, you hit the math button, which is on the left column, and then you choose option 5, which I think kind of looks like why? Looks like that. Has a little X by the square root. And then you can type it in from there. Did that answer your question?
Yeah, thank you.
Okay. I feel like I got away from myself there because it kept freezing and then I didn't know what was going on. Okay, where am I? Solve for P naught. Right. So now we gotta solve for P naught. So you get to pick whichever one of the two original equations makes you happier. And again, because I'm trying not to take the shortcut route, I'm gonna use the 207 and the 17th power run 1. But now since we know what A is, we essentially plug in the value we just found for A. Good, Daniel?
I'm good.
Okay. So if we just do some algebra here, if we take that to the 17th power, we're going to have 14.8515. Divide both sides by that. You're going to get P naught is that division, which is approximately 13.938. And here's where I have to talk about things a little bit. Now, a few minutes ago, I said that we knew what P naught was, and P naught was 14, and that's not 14. The reason it doesn't match up is because of the rounding we've done, and that is just an unfortunate thing that happens with exponential functions, is that the more you round at each step, the worse your numbers are going to be. In general, if we didn't know that P naught was 14, and the reason we know that P naught is 14 is because that's the value when T is 0. If we didn't know P naught was 14, we would say P naught is 13.938. Like, we'd just call it an A. But since we know, and again, so, well, let me just write this first. Since we know P naught is 14, I'm going to use 14 in the actual equation. So, well, then you could say to me, well, why the heck did you just go through all that if you were just going to make it 14 anyway? Again, I just wanted you to have the full process done for you. If you know what P naught is, you can kind of skip this step and just use the P naught that you're given. In terms of Wiley, if you're given P naught, use that P naught, okay? If this was a question on an exam or a quiz and you decided to use the 13.938, I wouldn't care. Wiley will. So just be a little careful. Figure out if you actually know what P naught is. Sometimes you don't, which is why you need this sometimes, which is why I did it. I'm not just doing things for giggles. Sometimes you do need that process. But anyway, since we know that P naught is 14, I'm going to use P naught is 14. Last step is to just make sure you actually write the equation. So since we wanted it in this format, we have 14, 1.172 to the t. So I'm going to scroll back up. I'm going to scroll back down in just a second, so don't forget. Oh, too far. And I wish this would highlight, but it's not, so I'm just going to circle it in red. So P naught is the initial condition, which you can also think about when t equals 0. So if you have the point 0 something, then P naught is going to be that something. It's going to be the number associated when t is 0. So since we had that one of the 2 points we had was 0, 14, since we have that point, we know that P naught is 14 because that's what happens when t is 0. Yep. Also, just a note for the homework for this coming week. There's a couple ones where like you're given a graph and you have to find the equation of the exponential function. Watch it catches up with me. Jesus. Come on, you can do it. I trust and believe. Oh, Jesus. That'll look like this. It gives you a graph, and it essentially gives you the y-intercept and then gives you a different point. Use that y-intercept, because remember, this y-intercept is going to be some 0, whatever that value is. So this will be your P naught, and you'll want to use that in Y01. So there's a couple questions like that where you're given a graph and you want to find the equation. You use this process to do so because you have 2 points, one right here and one right here. Once it catches up with me. So you have your 2 points, the y-intercept and A and B. So you use this process, except the fact that you can just use P naught as the y-intercept that you're given. So that's in terms of your homework for this coming week. So technically, we're not done this question. I know it feels like it's taken 5 years. Because we're asked, what is the annual % growth rate? So if you go back to the very beginning of the question, it asks, what is the annual % growth rate? And you can't see much. Just throw it all out. Throw the whole semester out. Come on, go. I'll just start dancing awkwardly, and no one wants that, so catch up with me. Thank you. All right. So we were asked for the annual % growth rate, and now you can't even read the word rate because I circled it too many times. So the word rate here, Jesus. So the word rate there should tell you that you're looking for the R value. So the last thing we want to tell them is what the R value is. Well, how do we find R? Well, we have to remember that A is equal to 1 plus R. So if we know that A is 1.172, well, if we swing this around, R is going to be equal, maybe I should write it like this so it might be easier to see why I got there. So if I subtract 1 from A, I get R. So then R is going to be 0.172, or you can always write it as a % as well. So this would be the annual % growth rate. In terms of Wiley, whether or not it wants the decimal versus the %, just kind of read the problem. If it has the word % in it, or it has a % symbol, it probably wants the %. If it doesn't and it says the word rate, or it doesn't have % anywhere in it, it probably wants the decimal. Okay. I know that was a lot, especially because all the problems I've been having with it lagging so much. Any questions on that? We're going to do another one exactly like this. Well, not quite exactly, but this same process again. So we will see this process again in this last example. But, okay. So I think we're good. All right. What up?
Why did you subtract the 1?
So let me actually scroll down a little bit. So A is 1 plus R, but R is the thing I want, so I have to get R by itself. So to get rid of that 1, I can subtract 1 from both sides. to get that a minus 1 equals r. So then I can just take my a value, because a is what I knew. So I knew that a was 1 point, whoops. Come on. 172. If I subtract 1 from that, that will give me my r value. Does that make sense?
Yes, thank you.
Race. All right. We might not get to 1.6, but that's all right. It'll be okay. Maybe I can start a few definitions. Anyway, rambling. Suppose we have q equals f of t as an exponential function of t is if f of 20 is 88.2 and f of 23 is 91.4. We want to do a couple of things. Essentially, at the end of the day, it wants us to find the equation and then plug something into it. So it kind of is the same type of problem as we just did. So they're using q's. So we're going to use q and q naught instead of p and p naught. But besides that, it's going to be the same idea. So the first thing we're asked for is the base. And the base is the a value. So to find the a value, that's where we need to divide the two equations. So we need to put these 2 points in the form of our equation that we're going to want, and then divide them. So we're going to use the larger t value first. So we're going to have 91.4. Don't know what q naught is. Don't know what a is. T is 23. And in this case, we literally don't know what q naught is. So here we don't even have a shortcut. We're going to have to do it the long way. And then the other point would be 88.2. Don't know what q naught is. Don't know what a is. T is 20. And so we're dividing these two equations, which again, the point of doing that is to have these q naughts cancel out because we have 2 unknowns and we can't deal with that. So we get those q naughts to cancel out. So we get 91.4 divided by 88.2 is going to give us 1.0363, and we're going to get a cubed. This is coming from 23 minus 20. We're taking the 2 exponents, and since we're dividing these 2 things with the same base, we subtract their exponents. So 23 minus 20 is 3. And then to finish solving for a, we have to cube root both sides. But cube rooting a cubed just leaves us with a. And if we punch that in a calculator, either with the cube root or a 1/3 power, that's going to give us that a is approximately 1.012. Which is what we were asked for in this part of the question. So we're done that part. And then part B. Find the percent growth rate. So again, that word rate is telling us that we want our R value. So once again, since A is 1 plus R, that means that if I subtract 1 from A, I can find R. So I know what A is, I just found it. So if I subtract 1 from it, I will get my R value. So R is 0.012 or 1.2%. And then in part C, we want to evaluate f of 25. So we would essentially say that we want to plug in 25 for t. We can't do that yet because we don't know what q naught is. So we need q naught first. And again, in this case, we don't have a cheat sheet way. We got to do the long way. I don't know what q naught is, so I got to find it. So remember, to find q naught, you go back to one of the original 2 equations. Pick whichever one makes you happier. The 88.21 makes me happier. Don't know what q naught is. That's what I want to find, but I do know what a is now. So I plug in that a value that I have. And now I can solve for q naught. So 1.012 to the 20th power is something I didn't write down. 1.012 to the 20th. So 1.26943. Let's take a decent amount of decimal points and try to make this as best as possible. Again, the more decimal places you take along the way, the closer your answer is going to be to the quote-unquote true answer. In terms of Wiley, when it comes to these, there should be a decent tolerance on it. So even if you round a bit differently than someone else does, it should still tell you you're correct. If you seem to be having issues with that and you really think you're right, you think it might be a rounding thing, let me know. But anyway, so now Q naught. So we're kind of getting, there we go. So Q naught is going to be whatever 88.2 divided by that number is. 1.26943. So we get that Q naught is approximately 69.48 if I take 2 decimal places, because then it's 0, 0 after it. So might as well just chop it off. So now that I know Q naught, I know that my full equation looks like this. And now I can actually do what it wanted me to of plugging in 25, which was the actual point of this part of the question. So if we plug in 25 here, that essentially just becomes a plug that sucker into your calculator. We're going to get approximately 93.62. And again, depending on how much you round when and where, your answer can differ slightly. I would also assume if you used the other equation, your answer might differ slightly. When I say slightly, I mean it should only differ by about, a couple decimal places. But don't freak out if like your answer looks slightly different than someone else's. So I actually just looked into it. If we used different color, if we used the other equation, the 91.4, we would have gotten that Q naught was 69.47. So just off by a 1/100th of a decimal point. And that's what I mean by your answer should be close. They might differ slightly, but you'll get about the same answers. And this is what I mean by Wiley should have a tolerance for that. But again, if it seems to really be screwing you over, just let me know. Whew. That felt like it took way longer than it should have, but oh well. Questions, concerns on this idea? We do have 10 minutes left, and I do want to try to get through some of the first definitions for 1/6, just so that we can chug along. So I will use a bit more of our time to get through a couple of those definitions, if there are no questions here.
I have a question, but it's about the homework.
Can we wait to the very, very end and then I'll answer it?
Sure.
Hooray! Because yeah, I can stick around after and answer some questions. I'll talk about the quiz at the very end as well. So let's just jump over to, whoops. Let's jump over to 1/6, which I do believe I already have pulled up. Maybe I don't. I guess I don't. So, crap, that's not what I wanted to do. One moment, please. So again, we're not going to get super into 1/6. We're just going to get some of the basic definitions set up. And then we'll call it a day. So 1/6. So 1/6, as you can see, is something called the natural logarithm. So say we're presented with the following situation. We have the population in Nevada in millions can be modeled by the following with T years since 2000. And then say I asked you to solve for t when p equals 4? Well, oh my lord. Well, if we kind of set that up, and it's lagging, so you don't see what I'm freaking out about. I'm just going to write it. Hopefully by the time I'm done writing, it'll catch up to me and magically appear. Maybe we won't get through any of this at all. Maybe I'll cry. There we go. So say I wanted to solve for t when p is 4. Well, that would give me this equation right here. And I circled it, but you can't see that. Anyway. So what we would want to be solving for is in an exponent. So how do I solve for something that's up in an exponent? Well, we're going to have to develop something that allows us to essentially undo that exponentiation and get kind of up to that t or get it down. We need to somehow get it to somewhere we can actually work with it. So that's how, that's what this natural log comes in. So the natural logarithm, full name, logarithm. So the natural logarithm of x, which is written ln of x, so that's an L, not a 1. And eventually there will be an x. There we go. Is the power of e needed to get x. So in other words, if we have the natural log of x equals c, this is going to mean that e to the c was equal to x. That definition in and of itself isn't going to come up very often for us, so you don't really need to remember that that's what that is. You just need to know how to use it, but that is technically what it means. The natural logarithm can also sometimes be written as log base e of x. And note that the natural log is not defined for 0 or negative numbers. If you pull up your calculator, if you pull out your calculator, there's a natural log button, and I should stress that. On your calculator, there's an ln button, and then above it, so I'm writing this backwards. So above it, there's also a log button. Unless you know what that log button does, do not touch it. Just touch the ln button, and you can't see the fact that I crossed it out because it's lagging. Fun. So don't use the log button, just use the ln button. But if you were to type in like ln of 0, it'd give you an error message. The very last thing I'm going to write is I'm going to write down these properties of logarithms, and then we're going to call it. And we'll see how they work next time. But just so that we have them written out, and I'll pull them up at the beginning of class on Wednesday so that anyone who didn't get them down can get them down again. But just so we have them down already and don't have to take the time to write them on Wednesday. If it's going to allow me to write. Let me do this one last time. Unshare. Reshare. If we have the natural log of some a times b, we can break this up as the natural log of a plus the natural log of b. Maybe we're not going to do these properties. Never mind. All right, I'm not, nope. Too frustrated with that. There it is. Right when I give up, it pops up. Well, you know what? Too bad. We're going to do the rest later. I'm done. All right. So we're just going to be done. I'm not putting up with this anymore. We'll fill out those properties on Wednesday and talk more about that. Not Wednesday, Thursday. Today's Tuesday. On Thursday. I mean Thursday. Anyway. So if you have questions, like one of you said you had a question on the homework, we can totally go over that now. And anybody else who has any questions, feel free to stick around. Otherwise, have a good day. Oh, your quiz. Let me put that in chat. Let me remind remind myself. Oh, I'm going nuts. I'm losing my mind. So let's see, quiz 3, what are you going to want to need to know? You're going to want to need to know stuff from 1.4. So how to write cost, revenue, and profit functions. Essentially given a situation. So like in your homework, there were things like you know, it cost them $500 to set up the website and $7 per t-shirt, and then they sell the t-shirts for $15, and you had to write the cost, revenue, and profit functions. That. Finding break-even points. No, Gabby, and I'll reiterate that in just a second. And then from 1.5, so what we did just cover, but don't worry, it's not anything super, super scary. You're going to want to know how to write the equation for an exponential function given context. And by that, I mean like example 1 in the notes. So the first one we went over where it was like adrenaline starts at 15 milligrams and increases by 3% each minute. That kind of deal. Not the deal where you do the 2 different points and have to go through that obnoxious amount of hoopla. Just the one where I say, this is the starting value, this is the percent that it's increasing or decreasing by. Can you find me the equation? That type of thing. So the stuff for quiz 3 is in chat if you want to look at it. Gabby, no. So reminder, I said this in the beginning, I'll say it again. As far as the homework that's due tonight, the 1.4 to 1.5 homework, you do not have to do the 1.5 problems. Again, if you already did, just shoot me an email, or David, I will make a note of that. Because what I'll do is I put all the 1.5 homework on this next homework for this week, the 1.5 through 1.7 homework. So you'd be essentially doing them again. So what I'm going to do is if you already did them, I'm going to go in and just manually put the points in so that you don't have to do them again. But anyway, the easiest way is to just not do them on the 1.4 homework set and to do them on the new homework set that just appeared today. Hopefully that makes sense. So the only thing that's due tonight is the 1.4 problems, which I think is questions 1 through 11. So you should only have, 44-ish points. If you got them all right in the correct amount of, attempts, then you will have 44 points. So first 11 questions. Quiz is there? All right. So other than that, if you don't have any questions, feel free to peace out. I will see you on Thursday. Have a good day. So what's going on with that homework question? Person who wanted to talk about homework. What are we looking at?
Gabby, she asked my question.
Oh, okay. Oh, it was just generic homework. Okay, got it. Good. Okay, well, I can hang around for a little bit if anyone's got questions, but otherwise, goodbye. Okay, David, if you want to just finish them out on the section that you've done, go right ahead. That's probably the easiest way to do it, to be completely honest. Well, no, it's up to you. It's up to you. You can either complete them on this homework set or do them on the new homework set, the ones that you haven't done yet. Whatever is easiest for you. So essentially the points that you earned on this 1.4 section for the 1.5 questions that you've done, I'm going to take those points and manually put them over to the new homework that they need to be on so that you don't have to do the questions again. Because that wouldn't be fair. So, but whatever is easiest for you, if you want to just complete them where you've already started them, that's fine. If you want to complete them in the quote unquote correct place, that's fine too. Whatever is easiest for you. Okay, sounds good. You might not see the points right away, but they will be up eventually. All right, if there are no more questions, I'm going to go ahead and end the call. I know people sometimes just walk away from their computer, which is fine. Oh, I haven't stopped the recording. Whoopsies.